Okay.
Right. So, after isotopes and after ions, right, there is a concept of radioactivity. And this is very important concept in this chapter. So this is very important because in some question, you observe that there is a name or there is a term radioactive element, right? So that is actually radioactivity that comes from radioactivity. So radioactivity is very important term. And what is radioactivity? We know that there are so many type of nuclear reactions, right? And we know about nuclear weapon, we know about nuclear bomb, we know about nuclear power plants. So all these terms with the name nuclear, so these are very dangerous, very harmful, right? We all know about it. We know about atom bomb, that is also the category of nuclear reaction. We will also study that how that atom bomb actually works and how we can like start up the reaction of the nuclear bomb. So that is also included in our syllabus. But before that, we have to know what is radioactivity actually. That is the basic thing. So radioactivity means, let's suppose if you have uh, a plastic bag, and in that plastic bag you fill it with completely with water, okay? And then you sealed that plastic pouch or plastic bag, okay? Now liquid is contained in that plastic pouch, okay? But let's suppose if you like make a hole in that plastic bag with the help of common pin, okay? So what happened after like 1 hour or after 2 hour with that plastic bag? There is a very tiny hole in it. With the like that hole is the size of the common pin, because in that plastic bag, with the help of the common pin or with the help of simple pin, you just make a hole in that plastic bag. So if we observe that plastic bag after 1 or 2 hours, so what will be your observation?
Water, the contents in the plastic bag will start to come out,
Yes. So
pour
basically,
out.
yes. In simple words, we will say that plastic bag is leaking, right?
Yeah.
So after this process, when the plastic bag starts leaking up, so definitely the quantity of liquid starts to decrease in the plastic bag, right? So, and this process continue, right? After a few time, it continues to decrease its mass by half, then more half, like this. Okay. So in the same way, there is a process of radioactivity, right? We discussed that there is a atomic number, there is atomic mass. So basically what happens that in atomic number or in atomic mass, there is a term mass, okay? And definitely there will be some mass of the nucleus, okay? So you can see in the definition it is written, it is the phenomena of emission of radioactive radiations from the nucleus of an atom, okay? So the water in the plastic pouch is the radiation, okay? And those radiations are coming out from the plastic bag. And let's suppose plastic bag is the nucleus of an atom, okay? So there is a mass of uh, atom or element in the nucleus, and after like some time interval, it starts to like leave that mass or lose that mass from the nucleus of an atom. That means emission. Emission means like to leave some part or like to take something out from uh yourself or your body, okay, or something other box. Like if there is a box and like after every 1 minute you start to take something from that box, so that means emission, okay? When something is coming out from some body, just like if we take example of the sun, so from sun we got sunlight, but also some thermal radiations are coming out from it. We studied in the thermal physics, right? The word radiation, you know about radiations, okay? That is completely like wireless communication without any source, okay? So what happens in the radioactivity? In radioactivity, there is the emission of the radioactive or like radioactive radiation from the nucleus of an atom. Okay, clear? Or in other words, just like we discussed the example of the plastic pouch and the water, you can write down the definition in different form. I think that is okay. That is fine. This is the simplest way to write down the definition, but this process is random and spontaneous. Okay, this is the definition. And if you take the example of periodic table, right? So in periodic table, there is an element named lead, okay, Pb. So there is an element Pb in the periodic table. So all the elements beyond lead are naturally radioactive, right? Like some elements are artificially, we can make them artificial by artificial way, but some are naturally radioactive, right? So those elements which exist beyond lead in periodic table, so all those elements are called naturally radioactive. Okay, radioactive means they are emitting out radiation from the nucleus of an atom. Okay, it means something is continuously coming out from the nucleus of an atom, and the thing that is coming out from the nucleus of an atom is radiation. Okay, so naturally radioactive means they have like the same example we discussed, there is a hole in the pouch and that water is continuously like leaking from it. So in the same way, radiations are leaking from the nucleus of an atom. Okay, and all the elements beyond lead in the periodic table are naturally radioactive. And this statement is only for your reference. They will not ask about the name, and you don't need to learn any name like these elements are radioactive, these are not. So we are not going to learn any name from periodic table. Okay, this is just for your reference. Like you can check from periodic table when you are like going to study periodic table in your chemistry chapter. So then you can like generally summarize like these elements are radioactive beyond lead. Okay, any confusion right now? Any
No,
question?
sir.
Okay.
Sorry, right now we did till the yellow part, right? The all element
Yes,
beyond
yes,
lead in the okay.
yes, we only discussed till this part. Now, the important concept related to radioactivity is that this process is completely a random process. Random process means there is no specific pattern or there is no specific particular time for it. So you can see the emission do not occur in any pattern, any nucleus decay at any time. It means when there is no pattern, so definitely you don't need to learn anything. Okay, because there is no specific pattern. How we come to know that this process will take place like this or in other way? Because this is completely random. We don't know about the pattern of any radioactivity element, right? So it happens by their own, according to their own time interval. Okay, so this is completely random process. Secondly, it is spontaneous also. Spontaneous means just like in thermal physics, we discuss some factors, right? Like this factor will increase or decrease the thing, just like we discuss about temperature, cross-sectional area, and temperature difference, color, texture. So we discuss so many factors in thermal physics, right? But in radioactivity, this process is spontaneous. Spontaneous means like if you change external conditions, like if you change the temperature of your surrounding, if you change pressure of your surrounding, if you change volume, if you change anything, so there will be no effect of these changes on radioactivity. Okay, clear? Any
Okay.
confusion? So whenever, like in any question, like if they ask if we increase the temperature, so what happens to the radioactivity of this element? So answer is very simple. You can write this radioactivity process or radioactive processes is spontaneous. It means there will be no effect of increasing temperature or whatever the condition is given in the question on radioactivity. Okay, clear? Any question, any confusion?
No.
No,
Okay.
sir.
So, sometimes in paper, they will also ask independently, like write down the definition for random or spontaneous in radioactivity. Okay, sometimes they ask about the definition. So that's why definition is clearly given in the notes. Okay, so you have to learn these definition. Secondly, this is the basic idea of radioactivity, right? Now, we are not going to learn the name. So what we are actually going to learn in radioactivity, we are going to learn about the basic or general categories of radioactivity. So there are three types of radioactivity. Okay. The first one is alpha ray or alpha particle. Second one is beta rays or beta particle. Third one is gamma ray. Okay. So we have three different journal types of, we can say, radioactivity. You can see these are not the name of the element in periodic table, right? These are journal representation of radioactivity process. Alpha rays, or you can say alpha particle also. Beta rays, you can also say beta particle. Why? Because these two category exist in particle nature. Okay, so these two type exist in the particle nature. So you can also write alpha particle, beta particle. That is also fine. But if you are writing alpha rays, gamma rays, oh sorry, beta rays, so these are also fine. It's up to you. But gamma rays are in the form of energy. You can see it is mentioned energy. So gamma rays exist in the form of energy also. Gamma will not exist in the form of particle. Okay, so this is very important thing to remember, that gamma only exists in the form of energy, but alpha beta exists in the form of particles. Clear? Okay, so we have three type of radiation: alpha, beta, gamma, right? Now the question is, if we consider any element from periodic table that is radioactive, so how many types of radiations are coming out from that element? Okay. So answer is very simple. It is mentioned single substance can emit either one or more than one radiation simultaneously. Okay. So it is not compulsory that one element only emits one type of radiation. Maybe it will emit two, or maybe it will emit three type of radiations. Okay. So it completely depends upon the element. And again, we are not going to learn any name especially for this process. Okay. But just for your example, just for your reference, it is there are some name given in the notes. You can see these are just for your reference. You don't need to learn these names. They will not ask about any name in physics. So in example, you can see radon. Radon gas, maybe you heard that name, but radon is an element and that only emit alpha particle. Okay, so radon only emits alpha particle. But if we compare thorium, right, in like question we also got the word thorium. So thorium emits alpha and gamma. Okay, but the third element, plutonium, plutonium emits all type of radiation simultaneously, alpha, beta, gamma, three of them. Okay, so it is not compulsory that one element can only emit one type of radiation. It's up to the element. Maybe that element emit three radiations in a single time, two radiations in a single time, one radiation in a single time. So it is completely up to the element. Okay, there is no proper structure that we have to study about this, and there is no proper procedure or method we have to write for this concept of radiation or emitting out of radiation. Okay, so any question, any confusion in radioactivity process?
No, sir.
Okay, so now we have three type of radiation, but we have now short of time in this class, so we are not able to discuss all the properties of alpha, beta, gamma, but we can compare their journal differences, right? Like the question is, what is alpha, right? What is beta and what is gamma? How we like identify that which one is alpha, which one is beta, which one is gamma? What are the charges or what are the like equations or what are the symbols? Just like we studied before about proton and electron. So if we talk about journal difference, so you can see there are properties given. So the first thing we are only talking about is nature, how they look like actually. Okay. So in nature, we can see alpha is exactly look like helium nucleus. Okay. So alpha is like the copy paste of the helium element. You know helium element 2He4, 2 proton, 2 neutron. So alpha is exactly the copy of helium nucleus, right? It is equal to the size of helium also and the property of the helium also, right? Clear? Any confusion? Okay. Next we have beta. So beta particles are fast moving electrons. So beta are just like electrons, right? Negative value. And the third thing is gamma. As we already discussed that gamma exists in the form of energy. So it means there is no concept of particle in gamma. So gamma are high frequency or electromagnetic radiations. Okay. For example, we know about X-rays, right? So gamma ray is more powerful than X-ray. Okay, it is in the category of X-ray, but it is like more powerful, more harmful than X-rays. So you know X-rays are not visible, right? They are not particle. They can easily pass our body through all the elements in our body, but they will not pass through the bone. And they can also weak the bones of the body. So you can like imagine that how harmful the gamma radiations are as compared to what we say X-ray. Okay. So these are the general concepts of radioactivity and their basic structure of alpha, beta, and gamma.